Hey everyone, and welcome back to the channel where we make science feel like magic. Today, we're diving headfirst into something truly electrifying. We're going to explore how a simple coil of wire and a powerful magnet can create energy, seemingly out of thin air. It's a principle that powers our world, from massive generators to the smallest devices, and by the end of this video, you'll not only understand it, but you'll see just how much potential this free energy holds. So, grab your lab coats, imaginary ones are fine too, and let's get ready to spin up some serious power. Alright, let's start with the basics. What we have here is a coil of copper wire and a strong neodymium magnet. On their own, they're just interesting objects. But when we bring them together in motion, something amazing happens. This is the core principle of electromagnetic induction, discovered by Michael Faraday way back in the 1830s. Essentially, a changing magnetic field creates an electric current in a conductor. So, when I spin this magnet near our coil, the magnetic field passing through the coil is constantly changing. This change gets the electrons inside the copper wire all excited and makes them start moving. And what is a flow of electrons? That's right, it's an electric current. It's like a magnetic dance that coaxes electricity into existence. No batteries, no wall sockets, just pure, clean energy generated from motion. Now, you might be thinking, okay, that's a cool science trick, but how much power are we really talking about? That's a great question, and to answer it, we need to look at a few key factors. The amount of current we can generate isn't random, it depends on several things. First, the strength of the magnet. A stronger magnet creates a more powerful magnetic field, which can induce a stronger current. Second, the number of turns in our coil. The more loops of wire we have, the more the magnetic field can interact with the conductor, multiplying the effect. Third, the speed of the rotation. The faster we spin the magnet, the more rapidly the magnetic field changes, and you guessed it, the higher the induced voltage and current. And finally, there's the resistance of the circuit. All these elements work together. To get the most power, we want a strong magnet, a coil with lots of turns, and we need to spin it as fast as we can. It's a beautiful symphony of physics working in harmony. Let's put this theory into practice. I've built a slightly more robust setup here. We have a larger, more tightly wound coil, and our magnet is mounted on a crank so we can get some consistent, high-speed rotation. I've connected the output of our coil to this multimeter, which will show us the voltage and current we're producing in real time. Are you ready? Let's start cranking. Watch the numbers on the meter. As I start turning slowly, we're getting a small reading. But as I increase the speed, look at that. The voltage is climbing. We're easily generating several volts just by turning this handle. Now, let's connect a load to it and see what happens. I'm going to hook up this small LED light bulb. And voila! With just a bit of elbow grease, we're lighting it up. It's bright, it's consistent, and it's powered entirely by the motion of this magnet. This isn't just a demonstration, it's a tangible example of converting kinetic energy, the energy of motion, into electrical energy. But can we take it a step further? A light bulb is one thing, but what about charging something we use every single day, like a smartphone? Let's try it. I have here a standard 5000 mAh smartphone. It's the kind of device that usually keeps us tethered to a wall outlet. I've hooked up our generator to a simple charging circuit to regulate the power and then connected it to the phone. Now for the moment of truth. I'm going to start cranking again, getting up to a good, steady speed. And look at the phone screen, we have the charging symbol. It's actually working. We are charging a modern smartphone using nothing but a coil, a magnet, and a little bit of manual labor. This is absolutely incredible. It proves that the principles of free energy aren't just theoretical. They have practical, real-world applications that can directly impact our lives. This little setup could be a lifesaver during a power outage or on a camping trip. So, we've successfully charged a phone. Now let's do some math to understand what's really going on. Let's say our generator is consistently putting out about 5 volts, which is the standard for USB charging, and we're managing to produce around 2 amps of current. To find the power, we use the simple formula, power equals voltage times current. So, 5 volts multiplied by 2 amps gives us 10 watts of power. That's a pretty respectable output for a homemade device. Now, our phone has a 5000 mAh battery. To figure out the total energy capacity in watt-hours, we multiply the capacity in amp-hours by the battery's voltage, which is typically around 3.7 volts. So, 5 amp-hours times 3.7 volts gives us 18.5 watt-hours. If we're generating 10 watts of power, and we need to supply 18.5 watt-hours, we can estimate the charging time by dividing the total energy by the power. That comes out to just under 2 hours for a full charge. Of course, this assumes 100% efficiency, which isn't realistic due to heat loss and other factors, so let's say it would take closer to 2.5 or 3 hours. Still, that is fantastic for an off-grid solution you built yourself. The implications of this technology are absolutely massive. What we've done here on a small scale can be scaled up dramatically. Imagine harnessing the kinetic energy that's all around us. Think about the motion of waves in the ocean, the flow of rivers, the spinning of wind turbines, or even the vibrations from cars driving over a road. All of this is kinetic energy just waiting to be converted into clean, renewable electricity. This isn't some far-off futuristic dream, it's happening right now. Large-scale hydroelectric dams and wind farms all operate on this exact same principle of electromagnetic induction. They just use giant turbines and massive generators instead of a hand crank. The potential is truly limitless. We have an opportunity to move away from our reliance on finite fossil fuels and embrace a future powered by the natural, ever-present motion of our world. This brings us to a crucial point, the idea of investing in and supporting free energy solutions. When we talk about free energy, we're not talking about breaking the laws of physics. We're talking about tapping into abundant, renewable sources that don't require us to burn anything or deplete finite resources. Investing in this technology means supporting research and development into more efficient generators, better energy storage solutions like batteries, and innovative ways to capture kinetic energy from our environment. It means advocating for policies that promote renewable energy and making conscious choices as consumers to support companies that are leading the charge. Every step we take, from building a small generator at home to supporting large-scale renewable projects, contributes to a cleaner, more sustainable, and more energy-independent future for everyone. It's a collective effort, and every single person can play a part in this energy revolution. Think about the possibilities. Imagine a world where remote villages have access to reliable electricity for the first time, powered by a local river. Imagine cities where the very movement of traffic and people helps power the streetlights. Imagine homes that can generate their own power during a storm, keeping families safe and connected. This isn't science fiction. This is the promise of harnessing the fundamental forces of our universe in a smart and sustainable way. The technology we've explored today is the key to unlocking that future. It's about more than just convenience, it's about creating a healthier planet, a more equitable society, and a brighter future for generations to come. The power is literally all around us, waiting for our ingenuity to unleash it. So, what can you do? Start by learning more. Be curious. Experiment for yourself if you can, safely, of course. Build a small generator like this one. It's a fantastic project that makes these concepts tangible and real. Talk to your friends and family about the importance of renewable energy. Support initiatives that aim to expand our use of wind, solar, and hydropower. The transition to a sustainable energy future is one of the most important challenges of our time, but as we've seen today, we have the tools and the knowledge to meet it. It all starts with a little spin, a little spark of curiosity, and a shared vision for a better world. Thank you so much for joining me on this electrifying adventure today. I hope you were as inspired as I am by the incredible power hidden within a simple coil and magnet. If you enjoyed this video and learned something new, please give it a thumbs up and consider subscribing to the channel for more deep dives into the science that shapes our world. And don't forget to hit that notification bell so you won't miss our next experiment. Let's keep exploring, keep innovating, and together, let's light up the future. Until next time, stay curious.